Using the equations of motion. First, write down suvat, s for displacement, u for initial velocity, v for final velocity, a for acceleration, and t for time. Then, fill in what you've been given in the problem, and make sure you convert to SI units as you go. At A level, expect the data to be given in something other than SI units. Make sure you have a list of the equations of motion to hand. You may well memorize them, but it's often easier to have them in a written down form as well. They do appear on the datasheet that you will have in the exam. Then, you pick an equation that contains just one term you don't know. You can only ever find one unknown term in an equation. Let's look at this problem. A car travelling at 20 meters per second accelerates at 2 meters per second squared for 6 seconds. Calculate its final speed and the distance travelled while accelerating. Well, firstly we write down suvat and put in the information that we've got. A car travelling at 20 meters per second, so that is our u value. It is in SI units. Accelerates at 2 meters per second squared, so that's our acceleration, which is also in SI units. For 6 seconds, that is our t. Calculate its final speed, so we need to find v, and the distance travelled s while accelerating. So we're looking for an equation that contains v and can contain u, a and t, but not s. The equation that fits the bill is v equals u plus at. We can now put in the values. U is 20, a is 2, and t is 6, giving a final velocity of 32 meters per second. We can now add that value for v here, and we may want to refer to it later. We now need to find the displacement, and we can have an equation containing any terms. So we might as well use s equals ut plus a half at squared. It already has the s isolated on the left hand side, so it saves us any rearranging. Putting in the values of u, t, a and t here gives a displacement of 120 plus 36, or 156 meters, which I'll add to my list. Another problem. A rocket takes 5 minutes from takeoff to reach a velocity of 6 kilometers per second. Calculate the acceleration and the distance covered. Well, as usual, our first point is to write down suvat. A rocket takes 5 minutes. Well, that is our time, but we want it in seconds, which is 5 times 60 or 300 seconds. Converting at this point saves us any chance of confusion later on. From takeoff, that tells us that u would be 0 meters per second. To reach a velocity of 6 kilometers per second is our v, but it's 6 times 10 to the 3 meters per second. So we've converted at this stage into SI units. Calculate the acceleration and the distance covered. So we're looking for an equation that will contain a and will not contain s. And the equation I'm going to use, v equals u plus at. I rearrange for a equals v minus u over t. Putting in the numbers gives us an answer of 20 meters per second squared. I'm going to add that value for a to my list here. Now I need to find the displacement s, and the equation I'm going to use, s equals u plus v over 2 times t. Putting in the numbers gives me a displacement of 9 times 10 to the 5 meters, or we could write that as 900 kilometres, which I will add to my list. And finally this problem, a cyclist covers 30 metres while accelerating at 0.5 metres per second squared from a speed of 8 metres per second. What is his new speed? Well, as usual, we start by writing down suvat and reading through the question. A cyclist covers 30 metres, that is our displacement, in SI units, while accelerating at 0.5 metres per second squared, that is our A, and it's in SI units, from a speed of 8 metres per second, that is our U, and it's in SI units. What is his new speed? Will be V. So we want an equation that contains V and cannot contain T. The one I'm going to use, V squared equals U squared plus 2AS. Putting in the numbers, I get that V squared is equal to 64 plus 30, so V is the square root of 94, which is 9.7 metres per second. And I can add that to my list here.